I've been thinking about the dice game, and if I keep halving the amount of red space available and doubling the amount of dice I have, will the probability that at least one of the dice lands in the red area keep decreasing?
Yeah, I've been wondering that as well. I've actually made a spreadsheet and I've been looking at it. What happens is the probability does seem to be going down, but it seems to be stopping around about 0.39346.
How do you work that out then?
Yeah, okay, so to begin with, half the box was red and we had one dice, and then a quarter of the box was red and we had two dice. And if we halve the amount of red again, we've got an eighth, and double the dice, 4 dice, and if we did it again, we'd have a 16th and 8 dice. And we can already start to spot some patterns, like this number is half of that number. I mean, that might be useful at some point. But if we think of what a tree diagram would look like for any one of these, let's say you had 4 dice, for example. If we think about the fact that we only care about the probability of it landing on white, because the rest of the big tree is going to represent at least one dice landing on red, we have 7/8, followed by 7/8 again, followed by 7/8 again, followed by 7/8 again. So this number here represents the number of fractions that we're timesing together, and the number on the bottom, the number on the top is one less than the number on the bottom. So the fraction that we're going to be looking at here is, if we call the 8 n, if we call this n, then this is half of n. We want to know what's going to happen to a fraction of this form. So that would be n on the bottom, n minus 1 on the top, to the power of a half n. That's going to be the probability that they all land on white. And so the probability that at least one of them lands on red is going to be that for any particular n that we choose, where n is the number on the bottom of the fraction here. So what we want to know is what happens to this expression, the value of this, as n gets bigger and bigger and bigger. So what I want to know is what happens to this expression as n gets bigger and bigger. We actually call this the limit as n tends to infinity. That's what mathematicians call it. It means as n gets bigger and bigger, is this heading towards some kind of target value that it's not going to go beyond. Now, let's have a think about it. So for this to be heading towards a value, then this bit needs to be heading towards a value. The 1 minus isn't going to change as n gets bigger. And also, n minus 1 over n to the n over 2 is just the square root of this. So if the square root of something is heading towards a value, then so should its square be. So if we can find out what the limit of this is as n goes to infinity, we can just square root it to find out what the limit of this is, and then we can subtract it from 1 to find out what our probability is going towards. That's the plan. So the thing about this now is to spot that it can be written in a slightly different way, like this. Now the thing that's interesting about that is that there's a special number in maths called e, and the definition of e is the limit as n tends to infinity of that expression. Now that is very similar to this, it's just got a plus where this has got a minus. Now, when you see two brackets that have the same thing inside but a different sign, you always think of, what do you always think of? Difference of two squares, don't you? That's what you think of when you see that. So can we use this idea to try and get our result? Right, so so we've got that multiplied by that. Now from difference of two squares, we know that that is equal to that squared minus that squared. So that's 1 minus that. Now these are to the power n, so let's put this to the power n, and that to the power n, and that to the power n. Now if we let n go to infinity, this bit here will become e, this will become the thing that we're interested in still. And this side, if n gets infinitely big, then 1 over n squared will just sort of shrink down to nothing. So this will be 1 minus 0, so 1 to the power n, and 1 to the power of anything is still 1, isn't it? So that means that as n gets infinitely big, this here becomes 1 divided by e. And 1 divided by e, according to the calculator, is 0.3679, let's say. But this, now, if we square root this, that should give us where this is headed to. So I'll square root this number. That gives us 0.60653,065. And if I subtract that from 1 minus that, we get 0.3934693, which is exactly what I got on the computer using Excel. So the answer to the puzzle is that if we keep halving the number of red and doubling the number of dice, the probability won't keep going down forever. It'll keep going down towards 1 minus the square root of 1 over e, which is 0.3935, but it won't go any further than that.
If you like this video, why not check out one of our other puzzles, and don't forget that we release a new puzzle every Monday. Also, like this video and subscribe to our channel.